Good evening, builders, and welcome to my workshop. Today I wanted to go over some of the ways that we make things in the woodshop, specifically related to the Piggy bank / toolbox project that we have going on right now. I went and did most of the cuts on my miter saw, so I wanted to run through real quickly so that you guys would have the benefit of the experience of building the kits, albeit vicariously. Since the miter saw is the tool that we're going to be using the most, let's go over some of the safety real quick related to using this tool. This tool is only designed for cutting across the grain. It's only designed for cross cutting. Under no condition should we ever be tempted to use it for ripping cuts like this. We're only going to cut across the grain like so. So when it's time to use it, you're going to squeeze the trigger back, pull it all the way back, push it down, and slide it through the cut. Like so. Once this blade has come to a stop, we're going to lift it up and set the board aside. Just a couple of quick tips for successfully and safely using the miter saw. When you're holding the board in place, you want to be applying pressure against the fence with your hand, keeping your hand well away from the blade. So the other thing we need to be sure to do is that we have the saw spun up before you try and put your cut. If you have the wood already in contact with the blade and you pull the trigger, it's going to throw the wood instead of cut the wood. That's kind of dangerous. So we're going to come back. Two more points and then we'll get started on the real project. Under no condition should you ever attempt to cut small stock. If you cut stock that's small enough that you can't have good contact with the fence, you're going to get your fingers pulled into the blade. It's really dangerous, it's really scary, it's a good way to lose a finger. If you need a small piece of wood of any dimension, you're always safer cutting a small piece off of a larger piece of wood, which will allow you to keep that good pressure with the fence and safely make your cut. Lastly, we need to talk about knots. These are the parts where the branches grew out of the tree trunk. They are a harder material than the rest of the tree, and they're also loose and not always tightly bonded into the rest of the material. So we do not want to either drive nails into them or cut them with the saw, as they can cause the saw blade to wander. I don't recommend you do this to your project, but here I'm pulling the knot out of one of the boards just to show you what it looks like. It does look like a stick because that's what it is. You will see that later in our project. This is a plan of all the cuts we need to make. You'll see that we have two end plates, two side plates, a bottom plate, and a dowel. This is what the completed kit looks like. The first end plate gets cut at 9 inches, so we're going to mark that with the scale, take a square and mark a straight line right where the cut needs to be. We're going to take that to the saw and we're going to line the edge of the blade up just with the side that we want to cut. So the edge of the blade should just touch the pencil line, and I've set up a stock block for the other side. The stock block makes this easy so we can make repeatable cuts. I feel like I should mention this isn't the safest format for a stop block because it doesn't flip out of the way like the safest stop blocks do, but it will do for what we're trying to do in this exercise. Push down, push through, wash, rinse, repeat, and we can make an awful lot of cuts rather quickly. You'll see right here we've got a broken end of the board, and I want to cut that off so that we can have a clean edge from which to push up against the stop block, and so that the project has a good edge to it. So just because we have the stop block doesn't mean we're always going to push the stock right to the end of the stop block every time regardless. So you'll notice that we're holding the board on whichever side will best support the stock. Sometimes if it's a short board, that means we're on the side with the stop block. If the board is longer, we'll be holding it on the side where the board is longest. Spin up, push it through, wait for the blade to slow down, pull the boards out of the way. For our next cut, we're going to need to be setting the saw to 30 degrees. This is the angle we will have with our project. Now this is technically a ripping cut, and I told you not to do this, but I'm going to see if I can get it. Oh no. We better find that finger and stop that bleeding. Okay, we'll put this in the Ziploc baggie, get it on some ice, and see if the hospital can put that back on for us. You can probably guess that I didn't actually cut my finger off in making this demonstration. I had intended just to spin the saw a little bit and not actually touch the blade to the wood. But it did contact the wood, and it kind of tore the wood in all kinds of ways as it pulled the thing sideways. Even with this little tiny cut right here, you can see it kind of messed up my saw. Everything's out of alignment now. It really was bad. I was able to keep my finger out of the way, but this was not a smart thing on my behalf. Please don't ever make rip cuts on the miter saw. The way that we're actually going to do it, we're going to set our saw to 60 degrees. This is going to allow us to make the angled cut at an angle that is safe for our saw to use today. So once we have that 60-degree angle set, we can start making our cross-cut style cuts in the saw. You can see we're still able to maintain contact with the fence. This is just long enough that we can make this cut safely on my saw. You'll notice that I'm pushing straight down on it instead of into the blade. We need to keep pressure on the fence and on the base of the saw. Pushing into the blade will only cause it to rotate. Here's one where we have a knot that can be cut out of the board during this process. So watch for opportunities to remove those knots and be careful that all the spots that will be accepting nails do not have knots in them. This is my drill press. It works pretty similar to the way a hand drill does. It has a switch on the front to make it turn on. And when you're ready to cut, you pull down on this lever to feed it in. There's lots of subtleties to this, such as how you can rig it, how to change the speeds and things like that we're not going to go over. Just be aware that this does have adjustable speeds and that you need to make sure the speed is appropriate for the material that you're working with and the bit you're using. Speaking of bits, the bit we're going to use for this project is a Forstner bit similar to this one. This is going to make a relatively flat bottomed hole that's going to be fairly smooth. So we're going to turn the drill press on by flipping the switch. Pull down on the handle on the side. It is set up so that it will stop at the bottom of where the hole needs to be, which needs to be half an inch deep. It's important that it be that exact and repeatable for the dowels to fit snugly and properly. The Forstner bit does a pretty good job of making a flat, smooth, round hole. It does need to be spun a little bit fast, but it does a good job of accomplishing this task. We have all our end plates cut and drilled and ready to move on to the next project. Notice that the edges do not have any knots in them. The side plates need to be cut 16 inches in length. We're going to mark that. Grab our handy dandy adjustable square, mark it with a pencil, put our X on the side we want to cut so we can keep track of which side needs to go away. We don't have room along our fence to install a stop block in this case, so we're going to have to put something together with some extra scrap so that we can accommodate the longer than the width of the saw cut, still being able to use a stop block. We have it set up so that the outer edge of the blade just cuts the pencil line right in half. So we're going to start making these cuts. Notice the longer amount of stock on the left-hand side of the saw means that's the side I'm gripping the stock for this cut. As the stock gets shorter, we'll transition from holding it on the left-hand side of the blade to the right-hand side of the blade so that we can keep that good pressure with the back of the fence. We need to stop periodically and check to make sure our boards are coming out exactly 16 inches in length. I want to show you this real quick where we've got a knot right where we need to make our cut. As you can see, 16 inches puts us right in the middle of the knot. This is not where we want to be making a cut. This is not where people are going to be able to drive their nails into the end of the board, so we can't use this piece of wood on the end. Now there's another spot I want to show you how we can deal with knots. You see there's a knot in the end of the board, so I can just shift the board over just enough to cut that knot out. Then we can continue to make the rest of the cuts so that we can have good pieces of wood that don't have knots right where the nails need to be driven. There are other flaws we'll need to watch for and cut out of the wood whenever we can. Here's a split in the side of the board. Now you're probably wondering, why do we have knots in our boards in the first place? Why not buy pieces of lumber that don't have knots in them? Well, you can. Here I am at my local hardware store, and you can see that all of the boards in my minivan that I was willing to pay for have knots in them. These are the 6 foot length. All these boards cost about the same per unit of volume. That all works out in the wash. It's priced on board foot and by the quality. In other words, all these boards are going to have knots in them. It's about $9 for the 6 foot boards that I was building this project with. Here you can see they do stock pine that does not have knots in it, but that same 6 foot board that we're picking up for $9 instead is pushing 28 bucks here. So more than 3 times as much money to buy pine that does not have knots in them. Now the dowels are going to come from the millwork section. That's the area where they have their molding and other such things. One thing to be careful of if you do end up buying this stuff is that this store prices it by the linear foot. The other store sells it by the stick, so I'm going to go to the blue place. We're going to start cutting the dowels, done the same way with a similar kind of stop block. It's important that we get that 15.5 inch dimension real exact, because that is what's going to pin the two halves together and drive the ultimate length of the toolbox. So we're going to check the fit real quick and make sure that the dowels are fitting in the holes. And we're going to check to make sure that the side plates line up perfectly with the length of the toolbox with the dowel installed. So the dowels are not going to be immune to knots either. So in this cut here, you can see we've spaced it such that the knot is going to fall in between two of the dowel cuts. We're going to cut this dowel out, and then we're going to cut the flaw out so that it doesn't show up in anybody's toolbox. And that's the last of the dowels. So let's get these over with the rest of the kits. Besides knots and cracks, there's another thing we need to watch out for, and that's staples. You'll see that the price tags on some of these boards is held in place with a staple. When we're lucky, they'll use stickers, but even when they're using stickers, they're still going to be stapling paperwork to the sides of the pallets of lumber with metal fasteners. So we need to get all those out of the boards to make sure that we don't end up with any of those touching the saw blade. If you can pull it out whole, we can use that piece of wood. If you break off the staple inside the wood, we're going to need to cut that section out so we don't risk damaging a very expensive saw blade. The bottom plates are marked at 14.5 inches. We can do the same as before. Mark it with a pencil, scribe a line with the square, and we're going to make sure and put that X on the side of the cut that's going away so we can make sure the kerf or the thickness of the saw blade doesn't end up cannibalizing any of our piece. We're going to use the same stop block setup as before. We're going to push the blade down without it spinning just to check to make sure that it's set to the correct distance. As you can see, that outer edge of the saw blade just touches the pencil line, so the pencil line will get cut in half. Same as before, slide the stock up against the stop block, hold it tight against the fence, spin up the saw, plunge it down to the material and push it through. Wait for the blade to come to a stop, lift up the blade, pull your stock out of the way. There are of course other tools we can use to make these kits. Here we're using a hand drill with the same Forstner bit to make our blind holes. You can use hand saws. Now make sure that you know which type of saw you're using and that it's going to leave you the appropriate finish. This is a push saw that cuts on the push stroke. This is a pull saw that cuts on the pull stroke. Leaves a little bit better finish. Another saw that would work would be the jigsaw. Make sure you use a good quality blade and you can get a pretty okay finish out of this particular tool. Another tool that would work well would be a skill saw. If you're going to use one of these, it's helpful to use an aluminum speed square on the side to help cut straight. Now, we cut them at 60 degrees so that we could have this cool angle on the right. If you need to cut them at 45 degrees, that's okay too, whether you're miter saw or you're trying to do this with the skill saw. If you do this with a skill saw, the 45 degree works well because you can cut it with the speed square. And there we have it. 45 kits worth of boards ready to go out for people to build toolboxes and piggy banks.